Hello and welcome to this tutorial. We are continuing the series of Spark plus PySpark. Today we are going to discuss about out of memory exception in Spark. The out of memory exception can occur on both driver and executor side. We can have it as driver out of memory and executor out of memory. Let's understand both of them in detail. Driver out of memory. Before understanding the reason and detailed overview of this driver out of memory, let's understand the type of driver memory. First would be spark.driver.memory. That is going to be the memory that is used by Spark primarily to handle all the JVM processes. For example, sending tasks to executors, scheduling and tracking data, and showing results. Second kind of driver memory could be driver.memory.overhead. This memory will be used by Spark to handle all the non-JVM processes like storing the container information, storing the user objects, etc. If you want to get detailed knowledge on the types of memory, I would suggest you to refer my previous video on Spark memory management. Let's get back to our topic. Now we are going to look into the scenarios where this driver out of memory exception can happen. First reason could be collect operation. To understand the driver out of memory using this collect operation, I'm just considering that I have a big data file that has been partitioned into 3 partitions, and all 3 partitions are sitting on 3 multiple executors. So if you see into this diagram, this big data file has been partitioned into 3 partitions, and these partitions are sitting on 3 executors named as executor E1, executor E2 and executor E3. Once we split this file into 3 partitions, these 3 partitions are going to be executed separately by each executor. Once this execution is going to be completed, and if we write that collect operation within this Spark job, the moment you execute the collect operation will move all the partitions data from each executor to the driver to display the final output. As soon as we call the collect operation, Spark will try to merge all partitions on the driver to create a single file of data that is going to be single partition, and this single file can be very big when it comes back to driver node, and it may exceed the memory assigned to the driver node. So for example, if driver is assigned with 1 GB of data and the data frame process was of 2 GB, then you may see out of memory exception at driver. This is how driver can raise out of memory exception by calling the collect function. Now the solution of this problem is avoid using collect function or set a kind of maximum driver memory. If you know your data frame is of 2 GB, then try to set at least 2.5 GB of memory to your driver node. Second reason of this driver out of memory exception could be broadcast join. So for understanding this broadcast join and out of memory exception within the broadcast join, I'm just considering a situation where I have 2 big data files. My file 1 is of 8 GB and my file 2 is of 2 GB. File 1 has been partitioned into 4 partitions, and file 2 has been partitioned into 2 partitions. So if you see in this diagram, file 1 have 4 partitions and each partition is sitting on each executor P1, P2, P3 and P4. And the file 2, that was a small file of 2 GB, has 2 partitions named as P1 and P2, and they are sitting on executor E2 and E3. Now, in such scenarios where we have one big data file and another small file, We will shortly think to have a broadcast join and broadcasting the small data partitions to driver to reduce the shuffling of data. For broadcasting small table, Spark will bring these small file partitions from executor to driver and merges it at driver node as a file of 2 GB. See, initially we partition the big data file into 4 partitions and small data files into 2 partitions. But when we are thinking of this broadcast join to avoid the maximum shuffling of data, we will again broadcast the small data partitions to driver node to combine it and merge it as a file of 2 GB. Now, this 2 GB file may breaches the memory capacity of driver, which has 1 GB of memory on driver node. This is how on the driver side we may get driver out of memory issue. How we can avoid this issue? We can increase the driver memory as per our requirement, or we can consider not broadcasting the table that exceeds the driver memory. Look into any other kind of available optimization technique instead of broadcast join, and it could be repartitioning of data, salting and others technique too. Moving forward to executor out of memory. For going executor to be out of memory, there could be multiple reasons. First reason could be yarn memory overhead. To understand this yarn overhead memory out of memory exception, I have created the detailed diagram of Spark executor container with all the available memory. You see in the diagram we have executor container, and within this executor container we do have overhead memory and on heap executor memory. So this on heap executor memory is further going to have some parts as storage memory, user memory and reserved memory. So you can see within this on heap memory we do have 3 portions: on heap memory, off heap memory and overhead memory. Whenever executor go out of memory, most of the time the reason would be yarn overhead memory, which will run short of memory, causing executor out of memory. Now this question may arise, what is this overhead memory and how it raises executor out of memory exception? Overhead memory is used to store hash tables of strings and internal objects of Spark. Overhead memory will be extra from the spark.memory.executor memory. It will be calculated at max 384, 10% of Spark executor memory. So as I told you, this overhead memory is going to responsible for handling all the non-JVM processes, and it would be around 10% of Spark executor memory. So if you are using any language other than Scala like Python or R to execute the Spark job, then all the objects of these languages will be stored in yarn memory overhead. This is how memory overhead could raise executor out of memory. To avoid this executor out of memory, we should consider increasing the yarn overhead memory as per executor requirements. The second reason of executor out of memory could be high concurrency. To understand this, we are considering we have a cluster with multiple executors E1, E2 and E3, and all the executors have multiple cores within them. Let's suppose we assign 10 cores to each executor without thinking much about the machine or cluster capacity. If executor has 10 portions or cores, then obviously each core or portion will have its own metadata and own memory overhead requirements. Total memory available to the main overhead memory will be divided into all cores and portions available within the executor. Now each executor will have huge amount of metadata and overhead memory requirements. It might be possible that machine or cluster do not have such memory configuration to meet these requirements to store huge amount of metadata and overhead memory requirements. It might be possible, like in these scenarios we may need more cores within each executor, and if we do not have huge amount of codes within each executor, Spark executor might race executor out of memory